Welcome to MRL. In this learning session, we'll be learning the solutions of the exercises of the quadrilateral chapter of 8th grade Ganita Prakash 8th standard CBSE textbook. Now, in this example 5 given to us, we are given two rectangles, that is PAIR and RODS. So, pair and rods are the two rectangles, and as we know, all the interior angles of rectangles are 90 degrees, but we are also given that angle ORI is 30 degrees. Now, we have to find angle IOD. Now, if you take the triangle ROI, one angle is 30 degrees here, that is ORI is 30 and OIR is 90 degrees. So, 30 plus 90 is 120, and therefore the angle ROI is 60 degrees. So, we have got 60 degrees. Now, if you take the rectangle RODS, then angle ROD is 90. ROD is 90 definitely, that is why I have written here, and we have got ROI is 60 degrees, so 90 minus 60 becomes 30, therefore angle IOD is 30 degrees, a simple example. Now we are given the diagonals of a square are 6 centimeters each, and we have to construct a square. That means both the diagonals are equal here. So the method is very simple. First draw the diagonal BD, that is BD is the line segment and we can take it as a diagonal. So draw BD first of 6 centimeters. We have to locate the midpoint of BD. For that, draw a perpendicular bisector to BD. Therefore, let us take this as XY. XY is a perpendicular bisector drawn to BD, and the XY by perpendicular bisector not only divides BD into two equal parts but also is 90 degrees. And now with the intersecting point, if I take this point O as the midpoint of BD, then with O as the center and measure of 3 centimeters, cut an arc and locate the point A. And similarly, O as the center, cut an arc again on the perpendicular bisector at a distance of 3 centimeters and locate the point C. Now we have located point A, point C, and we know the points B and D. Now join AD, AB, BC and CD. Then ABCD is 100% a square. The reason is all the four sides are equal and the diagonals bisect each other, and the diagonals are equal and the diagonals are perpendicular to each other. Therefore, ABCD is 100% a square. That is how we construct it. Now coming to the next example, we are given that case is a square. Case is a square. So by construction we can that case is a square. That means all the sides are equal, all the interior angles are equal to 90 degrees. Now we have to locate the midpoints. U, V, W, X are the midpoints of the square, and the midpoints are joined by the line segments UV, VW, WX and XU. Now we have to confirm what type of quadrilateral is found by joining the midpoints of the given square, and also we have to prove it by construction, by measurement and also by geometrical reasoning. By measurement it is simple, just measure the sides of the quadrilateral, they are all equal, but again we have to confirm as to why it is a square. Let us understand that. Now by geometrical reasoning, let us go for geometrical reasoning here. Now we know that VW is equal to WX, U is equal to UX and VU. All sides are equal. I have measured it. It is 4.2 centimeters. Angle U, angle V, angle W, angle X are measured. They are all 90 degrees. Therefore, UVWX is a square. That is by construction and measurement. Now by logical method, in triangle UCV, if you take this triangle UCV and UAX, I am comparing these two triangles here. Now this angle C is 90, angle A is 90, and angle that is UC and VC are equal sides, therefore angle 1 is equal to angle 2. Same way UA and AX are equal, therefore angle 3 is equal to angle 4. Now this is 90 degrees, that is angle C is 90, angle 1 is equal to angle 2, but angle 1 is equal to angle 2, and the angles are 45 and 45 degrees. Therefore angle 1 is 45 and angle 2 is also 45. Same way here, angle A is 90, angle 3 and 4 are equal because they are angles opposite equal sides, therefore angle 3 is 45 and angle 4 is 45. Now you see that CUA is a straight angle. If angle 1 and angle 3 are 45 and 45, that means 45 plus 45 is 90, therefore angle 4 is 180 minus 90, therefore angle 4 is 90 degrees. So we have found out that angle 4 is 90 degrees. That means we have got angle VUX is 90 degrees. Or you can even say angle U is 90 degrees here. Now same way, with the same reasoning, we have angle V 90, angle W 90, and angle X is also 90. Therefore the quadrilateral UVWX is a square. And also one more thing we have to understand here, because these two triangles are congruent, that is VUC, that is V or CVU and AUX are congruent, their corresponding sides are equal, and UV is equal to UX. For the same reason UV is equal to VW, and for the same reason VW is equal to WX, and VWX is also equal to UX. Therefore all the four sides are equal. So we have shown that all the angles, interior angles are 90 degrees and all the sides are equal, and therefore UVWX is 100% a square. So that is what is the proof of that by geometrical proof, logical proof. Now coming to the next example, we are given a quadrilateral. A quadrilateral has four equal sides and one angle is 90 degrees. So we have got four equal sides, 6 centimeter, 6 centimeter, 6 centimeter, 6 centimeter. They are all four equal sides, and we have one angle that is 90 degrees. Now we have to prove that the quadrilateral is a square by construction and measurement, and also by geometrical reasoning. Now in quadrilateral ABCD, we have AB is equal to BC is equal to CD is equal to DA, and that is 6 centimeters each. Angle A, angle B, angle C, angle D are 90 degrees by construction, because I have drawn the perpendicular, AD is perpendicular to AB, therefore it is 90 degrees, and all the angles are equal to 90 degrees. And we have to since four sides are equal and four angles are equal to 90 degrees, ABCD is 100% a square. Now the question is how to construct this square. Very simple. Draw a line segment AB of 6 centimeters, then draw a perpendicular AX to, that is AX to AB, and after that with A as center, mark AD 6 centimeters and locate D, and from point D again measure 6 centimeters, cut an arc, with from B as center again measure 6 centimeters, intersect the previous arc, then you locate the point C and then join AD, DC and BC, and that becomes a square. So that is how we construct the square. Now to prove this logically, what we will do, join BD. So join BD. Now in triangle ABD and CDB, we find that by triple S congruency, because AD is equal to BC, AB is AB is equal to CD, and BD is common. Therefore by triple S congruency criteria, all the corresponding angles are equal. That means we have angle 1 is equal to angle 4, angle 2 is equal to angle 3, and also angle A is equal to angle C. Now angle 3 plus angle 4, angle 3 plus angle 4 is angle 3 is angle 3 is equal to angle 4 is equal to 45 degrees, and angle 1 is equal to angle 3, and angle 2 is equal to angle 4. Therefore angle 2 plus angle 4 is 90 degrees, angle 1 plus angle 3 is also equal to 90 degrees. Therefore angle D is 90 and angle B is 90. So we have angle A, angle B, angle C, angle D are all equal to 90 degrees. Therefore a quadrilateral in which the four sides are equal and the four angles are equal, it becomes a square. Therefore ABCD is a square. So try to understand that, and whatever I have just spoken is already mentioned here, written here. We can go through that. Now coming to the next example, we are given the opposite sides of a quadrilateral are equal. The opposite sides of a quadrilateral are equal. Now we have to find the type of quadrilateral and also confirm it logically. Now we have a quadrilateral ABCD here. We are given that AB and DC are equal and also AD and BC are equal. So now to find out what type of quadrilateral it is, then what we will do, now join AC. AC is the diagonal here, and AC is the diagonal. So AB is equal to DC, BC is equal to AD, and AC is common. Therefore the triangles ABC and ADC are congruent. If they are congruent, then the corresponding angles are equal. That means angle 1 is equal to angle 2 and angle 4 is equal to angle 3, or angle 3 is equal to angle 4. Now if alternate interior angles are equal, then AB is parallel to DC and AD is parallel to BC. Therefore the quadrilateral ABCD is 100% a parallelogram. Now to find the sum of the angles of the given quadrilateral, we are given a quadrilateral ABCD here. Now we have to find out the angles of this quadrilateral by measurement and also by geometric reasoning. Now already I have written the angles here by which I have measured, but now we have to prove it logically also. Now for logical proof, let us join what you call BD. When I join BD, then I have got the angle A plus angle B plus angle C plus angle D is equal to angle 1 plus angle angle 1 plus angle 2 plus angle 1 plus angle 2 and plus angle 1 plus angle 2 plus angle 4 plus angle 6 plus angle 3 and angle 5. Now angle 1 plus angle 2 plus angle 3 is equal to 180 degrees because it is the sum of the angles of the triangle ABD, and also angle 4 plus angle 5 angle 6 is equal to 180 because it is the sum of the angles of the triangle BDC. So that means 180 degrees plus 180 is equal to 360 degrees. That is logically we have shown that the sum of the angles of this quadrilateral is 360. Otherwise also when we measure and add, we find that all the angles, sum of the angles is 360 degrees. Therefore the sum of the angles of the given quadrilateral ABCD is 100% 360 degrees. Now coming to the next example, to state true or false and justify the answer. A quadrilateral whose diagonals are equal and bisect each other must be a square. A quadrilateral whose diagonals are equal and bisect each other must be a square. It is not a correct statement. The correct answer would be it is a rectangle. The quadrilateral is a rectangle. It would be a square only if the diagonals are perpendicular to each other. Now the second statement, a quadrilateral having 3 right angles must be a rectangle. So quadrilateral in which 3 angles are 90 degrees, fourth automatically it is 90. Therefore it is the fourth angle is also 90. Therefore it is 100% a rectangle, and it is a true statement. Now the third statement is a quadrilateral whose diagonals bisect each other must be a parallelogram, and that is true. Now in triangle AOD and triangle COB, they are congruent by SAS congruency criteria. Therefore the corresponding angles are equal, and then the alternate angles are equal, and therefore AB is parallel to DC and AD is parallel to BC. Therefore ABCD is a parallelogram. Now coming to the next statement, a quadrilateral whose diagonals are perpendicular to each other must be a rhombus, but not necessary. Now you see, if you take the quadrilateral ABCD here, that the diagonal BD and AC are perpendicular to each other, but they don't meet the properties of a rhombus, and therefore it is not necessary that it will be a rhombus. Therefore the statement is false. A quadrilateral in which the opposite angles are equal must be a parallelogram. So let us understand this. Now we are given a quadrilateral ABCD. The opposite angles are equal. That is, if I take it as x and x, y and y, then x plus y plus y is 360 degrees. That is 2x plus 2y is equal to 360. That means x plus y is equal to 180 degrees. So if you take x plus y here, AB and DC are lines and AD is a transversal. If the cointerangles are supplementary, 100% AB is parallel to DC. And so also if I add x and y here, again it is 180. Again AB is the transversal, AD is parallel to BC. So we have got AB parallel to DC and AD parallel to BC. 100% ABCD is a parallelogram. Now coming to the next statement, a quadrilateral in which all the angles are equal is a rectangle. Now if you take a quadrilateral ABCD, that is, if angle A is equal to angle B is equal to angle C is equal to angle D, it is equal to 90 degrees, then AB is parallel to DC because cointerangles are supplementary, and so also AD is parallel to BC, AB is parallel to DC, and therefore it is a rectangle because it can be a parallelogram, but since the angle is 90 degrees, one of the angle, or rather all angles are equal to 90, therefore that parallelogram becomes a rectangle. Therefore ABCD is a rectangle. Now coming to the next statement, isosceles trapeziums are parallelograms. Isosceles trapeziums are parallelograms. It is a false statement because in isosceles trapezium one pair of sides are parallel, but the other pair is not parallel. Although they may be equal, AD is equal to BC, AD is equal to CB, but they are not parallel, and therefore it cannot be a parallelogram. So these were a few examples of the quadrilaterals chapter of Ganita Prakash 8th grade CBSE mathematics textbook. We have covered all the examples, the questions of each page, from page number 87 to page number 109, answering all the questions possible and also solving the exercises, and we have covered every question. So in 4 different videos, please go through all of them, learn them, understand them, practice them, and note all these examples in a book, and keep them as a future reference. So please do that. If you have any doubt, you can comment, you can convey whatever the doubts you have. I'll be able to clear them. Okay, thank you.